Good morning. I am Dr. Anitha DB, Associate Professor, CSE Data Science, ATME College of Engineering, Mysuru. Now I am going to demonstrate Experiment 5 of Machine Learning Lab. The statement is develop a program to implement k nearest neighbor algorithm to classify the randomly generated 100 values of x in the range of 0, 1. Perform the following based on the dataset generated. First one, label the first 50 points, that is x1 to x50, as follows. That is, if xi is less than or equal to 0.5, then xi belongs to class 1, else xi belongs to class 2. Second one, classify the remaining points, that is x51 to x100, using k nearest neighbor algorithm, and perform this for different values of k, that is k is equal to 1, 2, 3, 4, 5, 20, 30. Firstly we need to import the necessary libraries. The necessary library required are NumPy, Pandas, then scikit-learn. From that scikit-learn we need to import a k-neighbors classifier. Then in order to identify or in order to calculate the accuracy of that KNN algorithm, we need to import the matrix called as accuracy underscore score. So first thing, we need to generate the 100 random values in the range of 0, 1. So for that we have to use np.random.rand of 100. So this rand of 100 will give you the 100 values in the range of 0 and 1. Then step 2, label the first 50 points. Among 100 values, label the first 50 values. So labels is equal to np.array class 1 if x less than or equal to 0.5, else class 2 for x in x values colon 50. So this colon 50 will take only the first 50 values. So now consider this first 50 values as the training data. So x train is equal to x values colon 50 dot reshape of minus 1 comma 1. So reduce this data into one dimension data. Then y train is equal to label. So for any ML algorithm we need to have the data in terms of training set and testing set. So consider the first 50 samples as the training data, like x train and y train. X train is nothing but the values and y train is nothing but the label, whether it is a class 1 or a class 2. So now create a data frame for this first 50 samples using pd.dataframe. df1 is equal to pd.dataframe. So let us name that first 50 values like x1 to x50. So points is equal to for x x of I plus 1 for I in range of 50. So here from this we will get the points like x1 to x50. Then values, let us consider the first 50 values, that is generated first 50 values, and labels is equal to labels. We have already labeled the first 50 samples. Take it for the data frame. So the output looks like this: points, value and label. So 50 points, and what are the values of that 50 points and what is the class of those 50 points. Okay, next consider the next, that is the last 50 values as a testing data. So x underscore test is equal to x values 50 colon dot reshape of minus 1 comma 1. So it is consider the testing data in terms of one dimension. Then label for the remaining points. Okay, let us consider the true labels like np.array class 1 if x less than or equal to 0.5, else class 2 for x in x values 50 colon, that is remaining 50 points, true labels based on the condition. But we need to apply the KNN to identify the label for this testing values. Anyway, based on the condition we can also find out what may be the label. So let us consider that as a true label and also apply the KNN algorithm on the testing data and identify what is the label. So now apply the k nearest neighbor classifier. for different values of k. Let us consider the different values of k 1, 2, 3, 4, 5, 20, 30, and let us consider results is equal to an empty dictionary, accuracies is equal to an empty dictionary initially. Then repeat that KNN algorithm for k values. So for k in k values. Now select the model. KNN is equal to k neighbors classifier and number of neighbors is equal to k. For the first time k is equal to 1. Then knn dot fit. So fit the knn algorithm on the training data set. Knn dot fit x train comma y tree. Then predict the label for testing values. So knn dot predict of x test. Then save that prediction in the result dictionary. Then similarly calculate the accuracy. For that there is a function accuracy underscore score. Now for this pass the true labels which we have already found out by using the given condition. Then prediction. Prediction is obtained by applying the KNN algorithm. By comparing these two it will find out the accuracy and store the accuracy in accuracies of K. Then print the accuracy. So these are the different accuracy value for different values of k. Like k is equal to 1, 2, it is 100%, 3, 4, 94. Yeah, for all the remaining values of k it is 94%. Now again we can represent for the remaining data points in the form of data frame. Let us create a data frame pd.data_frame points like in the range of 50 to 100. So we'll get the points like x51 to x100. Then value x underscore values of 50 colon, that is from 51 to 100. So it will take the last 50 values. Then actual labels. So actual labels we have find out by using the given condition. So that is true labels. Then predicted labels, so that we got by applying KNN algorithm for different values of k. So here I have taken only for k is equal to 2. We can also consider, we can add more columns for individual values of k, like for k is equal to 1 what is the label, and for k is equal to 2, k is equal to 3, 4, 5, 20 and 30. But here I am showing only for the labels, that is predicted labels only for k is equal to 2. So if you run this, we will get the output like print df2. So this is the output for the remaining 50 points, that is the last 50 points. And we can observe the actual labels and the predicted labels. If you observe, this actual labels same as the predicted labels. And like this, if we go somewhere, we may get the misclassification. So I think anyway for this k is equal to 2, the accuracy is equal to 100%. So this actual labels and the predicted labels are same for k is equal to 2. And if you consider or if you create a data frame for k is equal to 4, so the accuracy is 94%. And if we go through those two columns, somewhere we got a misclassification. Thank you.